Right, number 244, merit level. Solve this second order differential equation and part the general solution. And if you're provided with these bits of information here, you can find the particular solution. Righty, so here's the question. And the key consideration is that's the second derivative, and we need to find the general solution, which is the first derivative function. Right, I'm just going to raise this up a bit. Okay, so f dashed of x is going to be the derivative, the integral of the second derivative with respect to x. Now there's a problem. So basically it's now you can't integrate this, so that's the problem. So what you're going to have to do is, if we looked at the formula sheet here, scroll down, look at double angles. So these are the trig identity proofs, and this is where they become quite useful. And what you need to do is take this one and this bottom one. I'll just write those down. Cos 2a equals 1 minus 2 sine 2a. And so this trig identity works. So we can rearrange sine squared in terms of this bit here. So just to do that very quickly, 2 sine squared a equals 1 minus cos 2a. Sine squared a equals a half minus cos 2a over 2. And in reality, let's just put a half out the front. Okay, if a was 2x, because that's what it's, the angle is 2x, therefore that's going to be cos 4x. And obviously the half has been taken out. So that was 2a. If a is 2x, so 2 times 2x is 4x. So that can be replaced with that. And the half and the 24 can be rewritten as 12 integrate 1 minus cos 4x with respect to dx here. So integrating that, let's just push this, just try to get the lighting here sorted. Try that. Okay, so that's going to be 12x cos goes to positive sign, so it's going to be sine 4x over 4 plus c1. I'm going to put a 1 here because it's the first constant of integration. If we expand it out, it's 12x minus 3 sine 4x plus c1. So that's what f dashed of x is. Now, the function f of x for the general solution is basically the integral of f dashed of x with respect to x. So we're going to integrate that, and that's going to be 12x squared over 2 minus 3 over 4. Sine goes to positive, because sine goes to negative cos. Negative gives you a positive, so it's going to be cos 4x, and I've already divided by 4 there, plus c1x plus the second constant integration for the second integral. Oh, okay, so there is the general solution. So a GS is f of x is equal to 6x squared plus 3/4 cos 4x plus C1x plus C2. Right, so part B, find the particular solution given that this information is useful. So let's just pause and highlight. Right. So that there is one expression, that's fx, and this one here is, so we're going to plug, when x is 0, this is equal to 3. So let's do this one here. So f dashed 0 equals 3. Okay, so 3 equals, put 0 in here. That goes to 0. Sine of 0. That goes to minus 3 sine of 0 plus C1. Now, what's the sine curve look like? So, obviously it's sine of 0, the value is 0. So this whole thing is 0. So we've got 3 equals C1 is the information in here. So that's going to be, well, that there's going to be 3 now. Okay, plug in this, f of O equals 2. So there we go. F of O equals 2. So 2 equals, put 0 on there, that goes to 0. Now what happens in here? 3/4 cos. What's a cos curve look like? Okay, so what does it suggest? Cos of 0 equals 1, whereas over here, sine of 0 was 0. Cos of 0 is 1. So that's going to be, well, 4 times 0, yeah, 0, yeah. So that's just basically times by 1. And that there was 3 times by 0, it disappears, plus C2. So you've got 2 equals 3/4 plus C2. And that is, just checking to see I've got the correct answer. And 2 is like saying 8 over 4. If we minus 3/4, you're left with 5/4, which is what C2 is. So the particular solution, as requested up here, f of x equals 6x squared plus 3/4 cos 4x. The C1 we worked out to be 3, so that's plus 3x, and the C2 term is this fraction 5 over 4, and that is the official answer. So that's a reasonably involved merit, and the tricky bit, apart from being a second order differential, was you had to do this bit of trig identity. Use this trig identity here to rearrange the sine squared of the angle into a format which you could then integrate. And with that in mind, there's some fiddly bits in here. The information was useful because the x value was 0, which meant these trig terms were nice numbers, 0 or 1.